Hello everyone and welcome to another Math tutorial video. Now I'll be discussing SPM clone 2004 from Form 5 Chapter 1 Progressions. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Alright, let me read the question now. The diagram shows the arrangement of the first three of an infinite series of similar triangles. The first triangle has a base of B and a height of h centimeter. The measurements of the base and height of each subsequent triangle are half of the measurements of its previous one. So let me show you the diagram now. Okay, so this is the diagram of the three triangle. As you can see here, the first triangle has the height of h centimeter and the base has the length of b centimeter. Okay, and this is the three triangle, guys. Okay, continue to read the remaining question. Show that the areas of the triangles form a geometric progression and state the common ratio. This is for the question part A. Okay, let me read the question part B. Given that B is equals to 160 centimeter and H is equals to 80 centimeter. Okay, continue to read the question part B. Determine which triangle has an area of 25 centimeter square. So this is for the question B part 1. As for the question B part 2, find the sum to infinity of the areas in centimeter square of the triangles. So this is the overall question, guys. So I hope that you will attempt this question in the future. If you could manage to solve this question, well done. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solutions now. So without further delay, let us start to discuss the SPM clone 2004 Form 5 Chapter 1 Progressions now. Alright, let us discuss the question part A now. Okay, for the question part A, the question asks us to prove that the three areas of triangles form a geometric progression and state the common ratio, guys. Okay, so what we're going to do now is we're going to find three separate areas, okay, of the triangle. Okay, let us start to find them. Okay, given that the area of triangle is equals to half times its base times its height, okay, we're going to start to find with the area of the first triangle. Okay, area of the triangle 1 is equals to half times with B times with H. Okay, this is already given in the question, guys. Okay, you have the base of B and the height of H. So when you calculate them together, you should get BH over 2 centimeter square. So this is your area of the triangle 1. Okay, so let us continue to find the area of triangle 2. Okay, so to find the area of triangle 2, we are still going to use the same formula, is equals to half times its base times its height. Okay, since in the question they mentioned that the measurement is subsequently will be halved from the previous one. So in this case, since in your first triangle is B, the base, so in this case your second triangle will be B divided with 2. So it will be halved of its previous measurement, guys. Okay, and the same thing goes for the height. Since in your first triangle you have the height of H, in your second triangle you will have a height of H over 2. So half times with B over 2 times with H over 2. So you calculate this together. So from here you should get BH over 8 centimeter square. So this is for the area of triangle 2. Okay, I hope you get the concept clear. So please stay with me. Now we're going to find the area of triangle 3 now. Okay, so area of triangle 3, okay, we're still going to use the same formula. Okay, half times its base times its height. Okay, in this case you need to be extra careful. Okay, half times with B over 2, you divide with 2. Because why we need to divide with 2? Half of its previous measurement. Okay, previous measurement is B over 2 from the second triangle. Since we are finding the third triangle, the measurement are getting halved from its previous one. Okay, the same thing goes for height, guys. Okay, your previous height you have is H over 2. When it comes for the triangle 3, it will get halved from its previous one. So half times with B over 2 divided with 2 times with H over 2 divided with 2. Okay, you calculate inside the bracket first. So from here you should get half times with B over 4 times with h over 4. Okay, then you calculate this together. So from here you should get your answer BH over 32 centimeter square. So this is your first step, guys. Okay, now you have already find area of triangle 1, area of triangle 2 and area of triangle 3 respectively. Okay, so now what we're going to do is we're going to check whether it's give us a same common ratio or not. If it's give a same common ratio between these three triangles, okay, then we can conclude that these triangles gives a geometric progression and a specific value of common ratio. Okay, let us continue to the next step. Okay, so to start off, we're going to check for T2 divided with T1. Okay, so actually the formula of common ratio in this case will be R is equals to T2 divided with T1. Okay, so let us continue to the next step. So in this case, T2, area of triangle T2 is BH over 8 and area of the triangle T1 is BH over 2. So BH over 8 divided with BH over 2. So this fraction will invert up since it involves a division, so it will become multiplication. So BH over 8 times with 2 over BH. So this BH and BH will cancel off. Okay, it will become 1 over here and 1 over here. So these 2 will become 1 and this 8 will become 4. So you times this together, you should get your common ratio for the first term, where T2 divided by T1 is 1 over 4. Okay, so let us double check the calculation for the common ratio again. So we cannot just conclude just by the first calculation, we need to prove once again. But in this case, we're going to prove for 3T divided by T2. Okay, so the same thing, guys, R is equals to 3T divided with T2. Okay, let us continue. Okay, the same concept, guys. Okay, 3T is BH over 32 and you divide with T2, in this case is BH over 8. Okay, since it involves a division of the fraction, so you become multiply 8 over BH. So BH over 32 times with 8 over BH. So this BH and BH will simplify, will become 1. Okay, this 8 will become 1 and this 32 will become 4. Okay, you times them together, you should get your second common ratio is 1 over 4. Okay, now you check and see. Okay, your both calculation have the same common ratio. Okay, guys, so from here we can conclude that this area of triangle has the same common ratio and it's actually a geometric progression. Okay, let me turn to the next page for the remaining working, so please hold on for a moment. So this is your final answer, guys. Okay, you can write in this way. So hence, area of triangle 1, area of triangle 2 and area of triangle 3 are geometric progressions with common ratio R is equals to 1 over 4. So this is your final answer, guys. Okay, let me discuss the question part B now. Alright, let us discuss the question B now. Okay, within the question B, we're going to start to solve the question B part 1. Okay, question B part 1 asks us to identify which triangle has an area of 25 centimeters square. Okay, for that, the first step what we need to do is, okay, we need to find the first term A, guys. Okay, how are we going to do that? Okay, remember that in the question they've already give the value of B is equals to 160 centimeter and H is equals to 80 centimeter. So what we're going to do is we're going to substitute these two values into the area of first triangle, which you've already find in the question part A, guys. In this case, given that area of triangle 1 is equals to BH over 2 centimeter square. Okay, you calculate this. So area of triangle 1 is equals to 160 times with 80, you divide with 2. Okay, this 60 you simplify become 80. So this 2 you simplify, you get 1. So 80 times with 80. So from here, you should get your area of triangle 1 is equals to 6400 centimeters square. So this is your first term, guys. Okay, so once you've already identified the first term, okay, and the common ratio is already found in the question part A. So what we can do is, now we can proceed to find the n value corresponding to 25 centimeters square. Okay, this 25 centimeters square is actually the Tn value. Okay, to find the Tn of the geometric progression is given by Tn is equals to AR to the power of n minus 1. Okay, substitute all the respective values here. Okay, in this case Tn is 25. A first term, which is the area of the first triangle, is 6400. R common ratio we have already find in the question part A, which is 1 over 4 to the power of n minus 1. Okay, now you can proceed to the calculation. Okay, 25 you divide to 6400, so from here you get 1 over 256 and you compare with 1 over 4 to the power of n minus 1. Okay, actually this 256 we can simplify to the base 4, guys. Okay, when you simplify to the base 4, you will get 1 over 4 to the power of 4. Okay, since your 1 over 4 and 1 over 4 is already has the same base in the both side, so now you're left with the n minus 1 and 4, guys. Okay, this base you can simplify. Okay, so you only left with the power n minus 1 and 4. So from here n minus 1 will be equals to 4. So from here you get your n is equals to 5. So this is your final answer, guys, where the fifth triangle has the 25 centimeter square. Okay, let me discuss question B part 2 now. Alright, let us start to discuss the question B part 2 now. Okay, question B part 2 asks us to find the sum of an infinity for the area of the triangle. Okay, to find the sum to infinity is equals to A, you divide with 1 minus R. Okay, so you substitute this value. So 6400 you divide with 1 minus 1 over 4. So from here you should get your sum of infinity is equals to 8533.33 centimeters square. Okay, this is actually in decimal form, or you can write also in fraction form, where you have 8533 1 over 3 centimeters square. So this is your final answer. Alright, that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future. Thank you everyone for your support, and I'll see you in the next video.